Hello. In this video, we're going to look at how we can work with radical expressions. So just a reminder of what we already know when we're dealing with numbers. We're looking for factors that are perfect squares when we're trying to simplify what we have here, a whole radical, square root of 405, into a mixed radical or a simplified radical. So we can start just by factoring it. Like I noticed that this is divisible by 5. But I am looking for perfect squares. So I do see that it's also divisible by 9, and 9 is a perfect square. So when I divide this by 9, I get 80. Well, no, I don't. I get 45, which is still divisible by 9. So I actually have two perfect squares, and they are the same. So I actually have 9 times 9. So I can treat this as being 9 squared times 5. The square root of 9 squared being 9, square root of 5 still just being the square root of 5. So that is the simplified or mixed form of this radical. That works pretty much the same when we have variables. So the 405 I already know is going to simplify into 9 root 5. X cubed, well, the square root of x cubed is the square root of x squared times the square root of x, which is the absolute value of x times the square root of x. And the square root of y to the power of 9 is the square root of y to the power of 8 times the square root of y, or y to the power of 4 times the square root of y. Now notice I don't need the absolute value bars around the y to the power of 4 because y to the power of 4 is always positive already. And in fact, for these sorts of expressions, while technically it is most correct to write 9 times the absolute value of x times y to the power of 4 times the square root of 5xy, that is technically the most correct. You can let the absolute value bars go. So again, we can have I would accept here 9xy to the power of 4 times 5xy, or the square root of 5xy. Although technically we should have the absolute value. So in the situation where we have an addition or subtraction inside that radical, we have to be very clear on the fact that it is factors that we can deal with here, not sums and differences. So before I can do anything with this radical, I need to have it in factored form. So this is the square root of 9 times x minus 5. Because 9 is a perfect square, I can then simplify this to 3 times the square root of x minus 5. But x minus 5 is not a perfect square, so I cannot simplify that any further. I do, however, also want to think about restrictions in the domain here. So x minus 5 has to be greater than or equal to 0, which means that x has to be greater than or equal to 5. That's a little more complicated in the previous example because I have x and y. So when we have two variables in the radicand, we're not going to worry too much about the restrictions. If I have operations like addition and subtraction, then I need to be dealing with similar terms. So as we already know from the example above, the 405x cubed times y to the power of 9, that one becomes 9xy to the power of 4 times the square root of 5xy. The second one, well, the x cubed y to the power of 9, I already know what that's going to turn into, so I need to think about the 80. 80 is actually going to be 16 times 5, so this is going to end up being 4xy to the power of 4 times the square root of 5xy. Now that I look at these, I have the exact same radicand in each case, and I have the same powers of the same variables out front in the coefficient. So these are like terms. Essentially, that xy to the power of 4 times the square root of 5xy is a common factor. So I can add the coefficients, and I get 13xy to the power of 4 times the square root of 5xy. And that is the simplified form of this addition. For multiplication and division, I don't need to worry about having the same radicand. I can actually, for example, with this division, just treat this as 75x to the power of 5 over 48x to the power of 2, all inside the radical. So I can simplify that fraction first before I worry about the square root. So 75 over 48 simplifies to 25 over 16, and x to the power of 5 over x squared is x cubed. 25 over 16, those actually are both perfect squares, so I get 5 over 4. X cubed is going to give me an x that comes outside, so square root of x squared, but I still have a square root of x that is left inside. So this is the fully simplified form. Because we only have one variable here, we'll talk about the restriction. X is inside a radical, so I know because of that x has to be greater than or equal to 0. But x was also in the denominator, so x actually can't equal 0. So when I combine those two restrictions together in this case, x has to be purely greater than 0, not equal to. And in the case of a fraction like this one, I can't really simplify it. It is already pretty simple, but we have a convention to prefer not to have radicals in the denominator. So if I wanted to rationalize this, I would multiply by root x over root x, ending up with 3 root x over x. And we would end up with the same restriction in this case. X has to be greater than or equal to 0 to be inside the radical, but it can't be equal to 0 because it's in a denominator and I can't divide by 0. So x has to be strictly greater than 0.